In this section, we're going to take a look at lighting and light mapping. These are the different ways in which we can add lighting to the scene, control lighting levels, and control how lighting is calculated. We'll also take a look at real-time versus baked lights and what the difference is between them. How can we control how lights behave during gameplay compared to what are the things that we can do in advance of gameplay to make the lighting look fantastic. So we'll take a look at real-time versus baked lights. You really don't want to miss this section because once you get a handle on the lighting tools, your scenes can look spectacular. In this video, we're going to take a look at the basics of lighting inside Unity, and we're going to explore some of the basic light types, like directional lights, point lights, and spotlights, and looking at the different controls we have available for these lights and the kind of impact they have on our scenes. In this section, we're going to be looking at the fundamentals of lighting and how lighting can have a major impact on our game and how appealing they appear. So we have a basic scene in front of us here, a completely empty scene with just a plane on the ground here, and this scene is completely devoid of lighting. You can find this project in the course companion files in the scene lighting basic, and we're going to be using this as the opportunity to demonstrate the different types of lights that we can create in Unity. And we're going to move on from there to look at the way lighting works inside Unity and in the real world more generally. So in this basic scene, I'm going to be adding a new light. You can see that by default, this scene doesn't have any lights at all. Inside the hierarchy panel, for example, we don't have any light objects added. So let's add our first light. To do this, I'm going to move to the top and choose Game Object, select Light, and then we get a range of different light types that we can add. We have the Directional Light, and this is good for simulating light that comes from an infinitely large light source. So for example, this might be good to create sunlight or moonlight. The characteristic of this light is that it's one really bright light that shines in a single direction. Here we have the point light, and this is good for simulating artificial light, like a light from a light bulb. Again, we have the spotlight, and in a sense that's pretty self-explanatory. This is a cone of light that has a direction. And then finally, we have the area light, and we're going to be seeing what that is a bit later. So I'm going to create a directional light as the initial light in a scene. I'm going to select that to create the directional light in the scene. And well, that's the directional light. I'm just going to move that into the scene here. And in fact, I'm going to create a cube object to demonstrate the effects of this light here. So you can see that we have our directional light in the scene, and it's casting light in this particular direction, and that's looking absolutely fine. If I select the directional light, you can see that we have an intensity slider so that I can increase the strength of the light. I can use the color swatch to select the color of the illumination. So I'm going to, again, maybe make that a slightly bluey color, like so. I can also use the shadow type setting to choose the kind of shadows that this object is casting. And so you can see here that again we have this light casting shadows in this direction. And I can use the strength slider to control the strength of those shadows. And you can see on the ground the effects that this is having on the shadows of this cube here. So again, I can kind of increase and decrease that. I can also change this to soft shadows to create a kind of soft edge to the shadows. But I'm absolutely fine with how this is at the moment. I'm just going to select this cube and just kind of make sure that it's resting on the ground plane. And I might actually just increase the size of the cube here, just so that I've got more control over how this is looking in the scene. Now you can actually select the light, directional light, and in fact you can select any light in the scene and change its type. By selecting the light and moving to the inspector under the type field, you can actually change this to any other kind of light type. So for example, if I wanted to make this a point light, I can select point light. And again, you can see that the controls for this become quite different. So I'm just going to switch this to a global axis here so we can kind of see how the point light works. So again, I can move this over here, and you can see again this is simulating an artificial light bulb. So I can just increase the intensity and kind of create an effect here for the point light in the scene. So this is good for simulating wall lights, particularly for wall lights or ceiling lights. So this is good pretty much for interior lighting. I can also change this from point to spotlight to create a spotlight. And when I do this, again, I can just kind of rotate this around to move this cone of light anywhere I need to. So I can kind of shine this here on the box. Maybe I can increase the range here, just so I can increase the range of the spotlight. And you can see that the range is really just extending the distance over which this light is affecting things. And again, I can also change the spot angle to widen the range of this light to something kind of like this. So again, we have a spotlight taking effect. Now, in terms of the computational complexity of these lights, the simplest kind of light is the directional light. And then the point and the spotlights are complex in their own ways. And for most reasons, we want to kind of reduce the number of these different lights that we have in the scene. The directional is the simplest kind, and point and spot, we should only really try to use these where necessary. The area light is a special case.